Hello and welcome to this video. We're going to learn about basic trigonometric ratios or identities. So if this happens to be your first time on this channel, please take a second and subscribe and also turn on the notification bell, and this will help you or enable you get updated or notified whenever we upload a new video. So when we talk about trigonometry, we are simply talking about the relationship between the three sides of a triangle and the angles of that triangle. There are three basic ratios that we are going to look at in this video. That is cosine, sine, and tangent. All the other identities that you know of, cosecant, secant, are derived from these three basic trigonometric ratios. Now we have a simple sketch of a right angled triangle. So we have this angle here as theta, and since this angle and this angle should add up to 90 degrees, let's have this angle as 90 minus theta. So let me label that angle as 90 minus theta. So what I want us to do is to name these three sides of this triangle in relation to these angles. Okay? Now we have three sides of this triangle. Let's start with this angle theta. Let's start here. So as I've said, we are going to name these three sides of the triangle with relation to this angle theta. Now the side that is just next to this angle is known as the adjacent line. So this is known as the adjacent line. Remember, we are naming these lines with in relation to this angle theta. And then the line that is directly opposite to this angle is known as opposite. Okay? And then we have the hypotenuse. Hypotenuse. So the hypotenuse does not change. So we have named these three lines or these three sides of the triangle in relation to this angle. What about in relation to this other angle? Angle 90 minus theta. So let's name the three sides of the triangle in relation to this angle 90 minus theta. So the side that is next to this angle is known as the adjacent. So this is the adjacent. So this is the adjacent line of this angle. Okay? And then the one that is directly opposite to this angle is known as the opposite line. Okay? And then of course the hypotenuse does not change. So after we have done that, let's learn now how to find the cosine of each of these angles. Now, the cosine of an angle that is abbreviated as cos, the cosine of any angle, let's say theta, is equal to the adjacent line of that angle divided by the hypotenuse. Okay? And then the sine, which is abbreviated as sin, of an angle, let's say theta, is equal to the opposite line divided by the hypotenuse. Okay? And then finally, the tangent, that is abbreviated as tan, of an angle theta is equal to the opposite line divided by the adjacent. Okay? Adjacent. So that is the way we find the cosine, the sine, and the tangent of of an angle. So we can have a look at one or two examples. Let us have a triangle, a right angled triangle, that way. Okay. And let's have this length as 3 centimeters and this one as 4 centimeters. And from that, let's try to work out. Okay, let's have this angle. Let's have this angle as theta. So let's try. Okay, let's have this as theta and let's have this as angle. Okay, let me call it x. Let's work out the sine of theta, the cosine of theta, the tangent of theta. Okay, and then after we have done that, we can find the sine of angle x, the sine, sorry, not the sine, but the cosine of x, and finally the tangent of x. Now, from the relationships that we have just looked at, we have seen that sine theta is equal to the opposite line divided by the hypotenuse. So here we are finding the sine of angle theta. So this is angle theta. So the opposite line of angle theta is 4. Okay? And then the hypotenuse. But when you look at this triangle, the hypotenuse is not provided. So we have first to find the value of the hypotenuse. And to get the value of the hypotenuse, we are going to use the Pythagoras Theorem, which states that the hypotenuse, okay, let me have this as A, B, and C. So C squared is equal to A squared plus B squared. So C squared is equal to 4 squared plus 3 squared. So C squared is 16 plus 9, which is 25. So it turns out that C is 5. So the value of the hypotenuse is 5 centimeters. Okay, so going back here, sine theta is equal to opposite, which is 4, divided by the hypotenuse, which is 5. Okay, as simple as that. So that is the sine of angle theta. Now, the cosine of theta from this relationship is equal to adjacent divided by hypotenuse. So the adjacent to this, or the adjacent line to this angle is this one, 3 centimeters. So cosine theta is going to be 3 divided by the hypotenuse, which is 5. Okay, and then finally, the tangent of angle theta is opposite divided by the adjacent. So the opposite of angle theta is 4, and then the tangent, the adjacent is 3. Okay, so we are through with angle theta. Let's move to angle x. And let's find the value of the sine of x. So sine x from this relationship is opposite divided by hypotenuse. So the opposite of angle x, or the line that is opposite to angle x, is this one, which is 3 centimeters. And then we have the hypotenuse as 5 centimeters. So the sine of x is 3 out of 5. Okay, let's go to the cosine. Sorry. So the cosine of angle x is equal to the adjacent, which is 4, divided by the hypotenuse, which is 5. So the cosine of x is equal to 4 out of 5. And then the tangent of angle x is equal to opposite divided by adjacent. So the opposite is 3 and the adjacent is 4. As simple as that. Let's look at another example. So let me draw a simple sketch of a right-angled triangle that way. So let's have this as 8 centimeters and this as 17 centimeters. So and this let's have this angle as theta. So go ahead and try to work out the sine of theta, the cosine of theta, the tangent of theta, and then go ahead and work out the sine of 90 minus theta, the cosine of 90 minus theta, and then the tangent of 90 minus theta. Okay, so you can first work it out by yourself, because I believe by now you have got some little knowledge about it, and then you can confirm whether what you did is actually the correct thing. So going by this relationship that we looked at, the sine of theta, so this is angle theta, so the sine of theta is equal to the opposite line divided by the hypotenuse, but we don't have the value of the opposite line, so that means we need to use the Pythagoras Theorem to work out the value of this length. Okay, and if you follow the Pythagoras Theorem, this is going to be 15 centimeters. Okay, so we have all the three sides now. So the sine of theta is going to be the opposite divided by the hypotenuse, so it's going to be 15 divided by 17. Then the cosine of theta is going to be the adjacent divided by the hypotenuse. The adjacent is 8 and then the hypotenuse is 17. And then finally the tangent is going to be the opposite, which is 15, divided by the adjacent, which is 8. So earlier on in this video, we said that since this angle and this other angle should add up to 90 degrees, this means that if this angle is theta, this one should be 90 minus theta. Okay, so when you are asked to find the sine of angle 90 minus theta, you are simply being asked to find the sine of this angle. Okay, this angle. Now, and going by the relationship that we have been looking at, the sine of angle 90 minus theta is going to be 8 out of 17. The cosine of angle 90 minus theta is going to be 15 out of 17. And then the tangent is going to be 8 out of 15. Now, there's a relationship that I want us to look at. Now, let's go to the previous example. Look at the sine of theta and the cosine of the other angle. For this case, it was x. Look at the sine of theta and look at the cosine of x. The cosine of x. Okay? What can you see about them? So you can see that the sine of angle theta is the same as the cosine of angle x. Look at the cosine of angle theta and the sine of angle x. So the cosine of angle theta is 3 out of 5. And then the sine of angle x is 3 out of 5. So you can see it's equal. Okay? Then let's go to the next example. The sine of angle theta is 15 out of 17. The cosine of angle 90 minus theta is also 15 out of 17. And then the cosine of theta is 8 out of 17. and you can see that the sine of 90 minus theta is also 8 out of 17. So you can see some relationship there, that if you have a triangle this way and you have this angle as theta, and as we have said, this other angle is 90 minus theta, so the sine of angle theta is the same as the cosine of the other angle, that is 90 minus theta. So this is an important relationship that we're going to look at in the next video. We shall see how to go about questions that involve this relationship in the next video. So thank you for watching, and let's meet then.